Hello, my name is Jonathan Taylor, and my project partners are Kyle Mowry and Colin Pro. Our project is the Assistive Strength and Movement Machine. We were able to perform this project through the Department of Engineering and Physics at the University of Central Oklahoma. Our advisor for the University of Central Oklahoma is Dr. Gangzu. What our project is, and the goal of our project, is to be able to create an early-stage physical therapy device which will decrease the recovery time after an injury to or surgery on the knee by introducing muscle strengthening earlier in the recovery process. How this will work is we will have a machine. In figure 1, you can see our machine. We will have this machine in which the patient will be able to put their leg on top of, and we will then have electrodes connected to the patient's hamstring muscles and quadricep muscles in certain locations, which I will get into detail later. And we will then record the electrical activity of the muscles as the patient tries to perform knee flexion and knee extension. We will do this by using electromyography, which is EMG. Using the EMG readings we receive, we'll be able to communicate through our electrical circuit, which is right here. Here's an up-close picture through our electrical circuit, which is connected to our linear actuator, which is on the bottom right there. We will be able to communicate to the linear actuator on how much assistance is needed for the patient to move their leg, move their knee from knee flexion and extension. What is interesting about this design is, as I had previously mentioned, is it requires the patient to perform or try to perform their own knee flexion and extension. By the patient having to put forth their own effort, this is encouraging muscle growth and strengthening. And so by doing this, the machine is helping strengthen their muscles, as well as preventing joint stiffness and increasing their range of motion as they are recovering, because we don't want to lose that. We don't want them to lose range of motion, and we also don't want their joints to become stiff. And so by performing these movements in between knee flexion and extension, those two things are being performed, as well as, due to our machine requiring them to do some effort themselves, they are also strengthening their muscles. So the muscle groups we're using for our EMG readings are the hamstring muscles and the quadricep muscles. These are your quadricep muscles on the top of your leg, and your hamstring muscles are the ones behind them. These two graphs right here are the latest EMG readings we performed. Before the black line, these are EMG readings with light resistance. Past the black line, these are EMG readings with high amounts of resistance. The top graph are the quadricep muscles, and the bottom one are the hamstring muscles. As you can see from these graphs, with the more resistance there is, or the bigger the EMG reading. So our device will be able to collect these readings and communicate that to the linear actuator so that the patient is not overworking themselves, because we do not want the patient to re-injure themselves. Our circuit down here is a EMG sensor. There will be two at the end of this. The two sensors, like I said, will be connected to the hamstring muscles and the quadriceps. Receiving those readings, it will be able to communicate to our Arduino Mega 2500, which will then communicate to the linear actuator. On our design, at a certain point, we know that the patient will become stronger and not really need assistance, and so we plan to implement resistance bands when they reach that stage of recovery. The goal is to be able to disconnect the linear actuator from the linear actuator plate and then attach resistance bands so that the patient is able to still perform workouts in between knee flexion and extension, still developing the muscle, so that, as we've been saying, so that they can recover faster, go and transition onto real machines, not real machines, but machines that are more familiarized with working out. So that is what our device is. That is the goal of our device. Is just that transition phase to be able to help the patient perform knee flexion and extension and develop those muscles shortly after injury or surgery. We would like to give a thanks to Emily Birch and Stephanie Spears, Dr. Stephanie Spears through Integris. They helped us in finding the best locations for our EMG readings. We'd just like to give them a special thanks. Thank you again, and I hope you find our project very interesting, and we would appreciate any of your comments. Thank you.